In this video I'll take you through some of the basic graphs you can use, and as the example data set we'll look at the how long till you blink file, and this was a project done by some students who were interested in how long people could go without blinking and if there was a difference depending on whether or not they were inside a building, I believe, in the shade, or if they were out in the sun, their hypothesis being that you had to blink more frequently if you were in the sun. And then they also asked them some other questions such as how much they had slept the night before. So here I've got the Excel file and I've just used the open worksheet function, and I'll open that in. And probably before I do anything else I might just save that as a project. Now if I save as a project it'll save everything I do, including all my graphs, whereas saving a worksheet only saves this actual data sheet here. And they have different file extensions. The MPJ is for a project, so I'll call this blink. So before I do anything I will just check that my columns have been labelled correctly. I can see that I've got time in seconds, age would be in years, sleep in hours, and these are all continuous or count variables. They're all numerical. And then here I've got three text columns: the eye cover, if the participant was wearing glasses or lenses or nothing on their eyes, their gender, and the area, in for inside and out for outside. So these are all categorical variables, they're all categories. If we're not familiar with the data, we might look at some of these categories in a little bit more detail before we start seeing if there's any relationship between any of these with the time they could go without blinking. So I might be interested to know if there was an even split in the people that they tested inside versus outside, and often I'll just do a couple of bar graphs or pie charts to look and see if these things are roughly equivalent. If I come here and go to, we'll try both of them, so let's try pie chart first. We want to chart the counts of unique values. That's in each value here is going to be counted up and put into a chart. And let's try the area. You can double click that, or you can select it and use the select button. You can go through and have a look at some of these if it interests you. Usually the default options will give you a decent chart to start with. So I can see that wasn't exactly the same. Slightly less tested inside than outside, but that would be the nature of an experiment where you're asking for participants and you have to recruit them in different areas. It would be unlikely to get exactly the same. So we can see that they had roughly the same inside and outside. What might show more of a difference is probably the eye cover. They've probably got, you can see here there's a whole lot of people that don't have any eye cover, and then there's the odd person that's wearing glasses or lenses, so you could scroll through that and look through. But let's try a bar chart of that. Again, we'll go to graph and the bar chart is here. Again, we want the counts of unique values, meaning it's going to go through and count each one in each category. Just the simple one is fine. And again, I'm just going to leave these at the defaults. And now we can see that we have most people had no eye cover, close to 100. So had quite a big sample, and then we've got, that looks about half, sorry, I mean half as in half of 20. I'm just looking at this tick mark here. About 10 with glasses and then just a few with lenses. Charts are nice just to look at your data. If you wanted exact counts you could go through and use some of the descriptive statistics, which I'll do in a different video. So those are for categorical variables. If we've want to look at some of the continuous variables, just as an overview, we might be interested in the range of ages of the participants. And so we could try any of these here. You'll see that Minitab groups graphs together which work for the same types of variables. So histograms, dot plot, stem and leaf. I might just try a dot plot where it will put a dot for each observation, and a simple one I'm just going to put everything together. I'm not going to split them into groups such as male or female just at the moment. So let's look at age. Okay, and so each dot on this on this plot represents one person, and we can see that most people are falling around this 24 mark, and that's not surprising if they were surveying people on a university campus. We have one much older person. They were game to participate in a student experiment. And we also have some younger people, which you would have to be careful with, because I don't think you could get that. You could do that without getting specific ethics approval to test on people under the age of 18. Now, what else could we do? So let's have a look at the time that people were able to hold their eyes open, and a histogram might be nice, and later on we might look at putting a curved fit over the top, but let's stick with a simple one for the moment. Okay, so some people, they look like they're clustered around 0. We're not able to go any time without blinking. They blinked almost immediately. They may not be sitting exactly on 0 because the data's been grouped. It's probably a bit after 0. And then we've got a few people, not many, who were able to hold their eyes open for a long time without blinking, 120 seconds. That's a very long time. We all ought to have a go and see how long we can hold our eyes open without blinking. Okay, so those are some basic charts. Once you've done, and out of interest while you're looking at these, you could start describing them. So this, you can see, is what we would call skewed to the right or positively skewed. It's been pulled out over on the right hand side. It's not symmetrical either side of what would be the mean, the middle around here. We might be interested in looking at the time split over another variable, perhaps looking to see if there is a difference with the inside and the outside. And if we want to look at one variable split into groups, often box plots are a nice way to look at these. So come down here, and this is our box plots. And this time, rather than the simple one, well, we can do the simple one first, and I'll show it to you. Let's just do time in seconds. And this is equivalent to the histogram, except instead of going across, it's going up and down. And this is handy for showing us the outliers. So the middle box is the middle 50% of people and what their time was, and this middle line here is the median. So if we lined up everyone in order of how long they were able to keep their eyes open, the person that was smack bang in the middle would be on this line here. And then the middle 50% of the people are in this box. Then you've got the top 25% and the lower 25% of people with these whiskers. And these marks mean that they're a long way from the rest of the observations, and they're called outliers. And this is another way we can see that the distribution has been skewed. It's been pulled out positively in the positive direction of the axis. And if you twisted that onto its side, it would be to the right. So that's just time for everyone altogether. If we split that into groups, we can see if there's any difference between holding your eyes open inside versus holding your eyes open outside. So let's do the box plot again, and this time we'll go with groups. So the first thing we put in is the variable we want to graph, and then we put in the categories or the groups that we're interested in. So it says categorical variables for grouping. And you can put more than one in here, and it will keep dividing the plot up each time you do that. So we'll try it with just one, and then we can have a look at doing it with two. They can get a little bit more difficult to read the more you put in here, and actually you have to have quite a bit of data before you can split over several variables at the same time. So let's split over area. And it's a little bit hard to tell if there's much of a difference. It looks like the median is a bit higher up for the people that were inside, in that it looks like maybe they're slightly more likely to hold their eyes open a bit longer inside. It's hard to tell if this is just random variation or if there's something statistically significant here, and that's why we will do testing later on. But at the moment with these plots, we can't really see much of a difference. I'll just show you adding another categorical variable in here so you understand what I mean by grouping over several variables at once. So we might also be interested in is there a difference in the area, whether they were inside or outside, but also is there a difference between males and females, whether one gender can hold their eyes open longer than the other? I can't imagine there's much of a difference between genders, to be honest. So if we put gender in here and click OK, we can see that we've still got inside and outside, but now we've got the females and the males split as well. So that would be one way of doing it. It's possible that we want to plot it the other way around. Sometimes you have to do a few plots and then just pick the one that's showing the aspect of the data that you think is most interesting. So if I take gender out of there, I'm just going to delete that. I'm going to put it before area and double click it again. Now they're in the opposite order, so it'll flip the order that they're in down the bottom here. So now I've got the females together and I can compare their in and out, and I've got the males together and I can compare their in and out, as opposed to having all the people that were inside together and comparing males and females, and all the people that were outside together and comparing males and females. So it depends on what the comparison is that you're interested in. If we were interested in comparing the genders, then we would probably want this plot here, because whether we're inside or outside, we can compare the genders. If we're interested in comparing the difference that being inside or outside makes within a gender, then we would be interested in this plot, because we can see within the females, is there a difference with the inside and the outside? And this data is not showing a huge amount of difference, and we can run some tests on this later to see if there's anything significant here.